Hi, everyone. I'm Idan, and I work in GitHub's Office of the CTO. And my team's mission is to explore the future of developer experiences. And when we reflect on the trajectory of development, particularly front-end development targeting the web, the first thing that comes to my mind is JavaScript fatigue. Right? In 2016, there was a year of excitement for the renaissance of JavaScript. ES6 had just been formalized as ES 2015, and there was a healthy dose of language improvements working its way through the TC39 process. So we had a bright future ahead of us from a language perspective. And at the same time, Node.js and IO.js had just buried the hatchet, resolving some big unknowns about the future of JavaScript on the server. Yarn and NPM were competing on performance and features, and all of us were the winners in that competition. And we had an explosion of frameworks and tooling to let us skip the wait and reach into the future and use all these goodies right away. We papered over runtime differences and deficiencies with layers of tooling. We figured out how to hot swap code at runtime with tooling. We figured out how to bundle code together for production with tooling. So in 2016, there was a moment where we all looked in the mirror and asked ourselves, is this glut of tooling, is all of this tooling, is it good? Because all of that tooling came with a cost. You had to configure it and you had to patch it. You had to work out the tricky interactions between the tools. This tooling promised magic, but we spent hours fighting brittleness. Being a front-end developer became as much about wrangling the tooling as it was about the writing of the software. And we did. More tooling proliferated, but ultimately most people coalesced around a handful of stacks. But in the intervening 5 or so years, something interesting happened. The underlying runtimes grew up. All of the polyfills and wrappers that we needed to support old browsers became moot when those old browsers dropped off the usage charts. It's at this moment that Fred's work on Pico and Snowpack and later Skypack are starting to look like the seeds of another JavaScript renaissance. Shedding the constraints of backwards compatibility is about more than just using the latest features or making production bundles smaller and faster. They open up entirely new developer experiences, and it's a fascinating moment to watch unfold. Fred's been on the front lines of this renaissance for the last few years, and I can think of few people who have such a credible, knowledgeable vantage point on where all this is going. Through his work on Skypack, he's been exploring futures where our dependencies aren't even on our computers. No node modules with 50,000 files or stuff like that. And how that model with no dependencies on your computer can improve the security posture of developers. With Snowpack, he's created an environment for development that's so fast that it feels unreal if you haven't used it before. And I don't need to sell anyone on the benefits of instant startup and magically fast updates and overall less tooling. So it's with a ton of excitement that I welcome Fred today to the OCTO Speaker Series, because I can't think of something more directly on theme for us than a look at the next 10 years of JavaScript. One final note before I bring Fred on, we're taking questions at this GitHub discussions thread. The URL is down here on the screen. I'll also try to keep an eye out for questions in Twitch chat. And I'll ask that you please keep things positive and welcoming to everyone. We've got a code of conduct in the repo that discussions thread is on, and it's really important to us that everyone abide by that. And so without further ado, welcome Fred.
Thank you so much for having me. I'm really excited to be here and talking about this with everyone today.
Our pleasure. Take it away.
As you mentioned, this is a space that I think a lot about. And anything that's looking into the future is essentially fiction. So this talk is science fiction at the end of the day. But I want it to be good science fiction. I want this to be like your favorite episode of Black Mirror, but not one of the ones where we all die or get killed by bees or robot dogs. Like, hopefully this leaves you with a sense of hope for where the internet is headed, like one of 2 happy Black Mirror episodes ever made, ever. But I don't write a lot of science fiction. I don't write much fiction at all. So doing this talk was a bit of a challenge. So first thing I did was I consulted the experts and tried to figure out what makes a good science fiction story. The first thing I learned while Googling around is that science fiction writers are constantly procrastinating. So 90% of all advice that I saw was essentially, stop procrastinating, stop reading this article, go write the damn thing. And, this is all nonsense. So that made me feel a little hopeful. I'm a pretty consistent procrastinator. So felt like that was, I was already kind of off on the right foot there. But looking past that, I kept digging and I found this really interesting quote, which I really liked. Talking about what makes a good dystopian kind of thriller sci-fi, and that its roots are really in the breakdown of self-policing. In the sane society, people keep each other in check. It's only when that breaks down that the government steps in with robot dogs and killer bees and brain implants replacing violent thoughts with compulsions to dance, in this case. Not really related to JavaScript, but I couldn't help just, as I read that, think of, every mean comment I've ever gotten on Hacker News as not just nonsense, but the linchpin of society, self-policing and gatekeeping actually keeping us from total destruction. I doubt that's the case, but that made me tickled to think of it that way. The main advice that I found, which I think is really relevant here, is that good sci-fi is all about exploring one good idea very deeply. So instead of throwing 100 ideas at the wall and next thing you know, you're on your spaceship to the moon base to talk to the queen of the sun, it all gets very messy. Good sci-fi can just be one real idea, but taken to the extreme, pushed out into the future, all the implications of that idea. And that's the model that I wanted to follow for this talk. Black Mirror, again, is like, they are the experts at this. They essentially had one of their best episodes was, Uber ratings, but for everything, and just an hour and a half of really compelling, really scary television about what happens when everything you do is given a score and a ranking. And, that's all they had to do. It was one idea that exists today, pushed out into the future. That's the model I want to follow here. So I want to look at the last decade of JavaScript and web development as a whole, look for patterns, and let's take one of those patterns and just push it out entirely, push it out into the next decade and see what happens. What can we expect from web development? What will our tooling stack look like in a world where things that are already happening today just kind of keep going? Those trends continue. There are some limitations to this, right? Alien attack. If aliens attack, I am not going to be building websites, I promise you. Whoever is building websites, it will look very different. Nuclear war, I assume I won't be building websites either. Kind of hope I wouldn't. Robot dogs and killer, huge technical innovations create a little bit of a trickiness in this, right? How can you predict something that is, by definition, groundbreaking? But I think it's actually a bit more accurate than you'd think. For example, I couldn't in a million of years figured that a foldable phone was even possible. But just because that exists today, I don't know if that necessarily means it's groundbreaking. Good for them for building it, but I don't know if that's going to define a decade of development in the same way an iPhone would. So, by sensing the trends, you can kind of tell not just, a groundbreaking technology is important, but does it actually change the way we interact with the internet? Does it change behavior? Is it connected to a larger human story, or is it just a gimmick? There's actually a Jeff Bezos quote that I really like, which, to be fair, is reeking of survivorship bias, but has this really interesting way of thinking of not just what the future will look like, but what things won't change. So really getting at those trends. What are the trends today that just will continue tomorrow? And using that to predict the future. So in Amazon's case, right, no user is going to say, I want higher prices, I want slower deliveries, I want less options. Jeff Bezos' point in this longer quote is that by focusing on those truths, you can actually get a really clear sense of what the future will look like, what people want, and what will drive them to the decisions they make in the future. the work I've been doing is really based on this idea. So Pico was a project back in 2018 that was trying to look at the future of web development. And Snowpack and Skypack, the two projects that came out of that, essentially are taking those human truths, those specifically developer truths, and turning those into products. So Snowpack is a faster web development environment. It's based on the idea that if you can have something faster in a developer world, you want it, right? No one wants a slower dev environment. And then the technology it's based on is just a means to an end in that story. You simplify tooling, you simplify configuration. Skypack's a lot the same way. And all the other things being equal, you don't really want like your packages and all the work that it takes to get those from downloaded from a tarball, eventually shipped to your user in JavaScript. You want something that's a little more on demand, and I pull the code that I want. If things are simpler, generally people appreciate that, and it's a good thing. So this whole talk is really based around that idea of what are these truths, what are these trends, can we pull them forward into the future, and what do we find when we do that? This is just an exercise, but built around the work I've been doing, the way that I've seen the web evolve over the last few years, and what we're building for into the future. So the first question to pull a trend out is we have to find out what that trend is. So what defined the last decade of web development? You know, as users, we replaced laptops and desktops with phones and tablets, and we use our fingers to interact with things now. More people got online than ever before. Billions of people connected to the internet for the first time, on all different sorts of devices, on all different sorts of connections. So what we build for now is no longer, you know, above the fold versus below the fold because you have this consistent, you know, machine. Instead, you're designing for a world where the user could look and behave like anyone. They could have a high-powered device or a low-powered device, a fast or a slow. The world of the internet is just more accessible than ever to more and more people. On the flip side, for developers, you know, cloud computing is this huge trend of the last decade where instead of me managing servers in my basement or as a company having to buy data center space and manage those racks myself, I just click a button and get compute or database or storage. This on-demand access model really for things that had traditionally always been high cost of maintenance and setup. Also for developers was this idea that JavaScript, especially for web developers, moved away from just being a browser language, and it moved essentially all the way down the stack. So Node.js brought JavaScript out of the browser and into the servers, you can build your API with JavaScript, you can talk to your database with JavaScript, you can build a front-end application, a native application, a desktop application. The last decade has really been about JavaScript's journey out of the browser and into just every other facet of development. NPM as a part of that is a single JavaScript ecosystem across front-end and back-end, one ecosystem of a community of packages and code that's shareable. And React specifically gets a call out because it took a model where the front end was really about getting HTML and CSS delivered and then adding functionality. React flipped that model where it said, no, it's really about defining parts of your site, of your application, and giving them the full control. So not just functionality, but also view, rendering, that component architecture of a front end. Took JavaScript not just from being the thing that makes your site run, but actually the thing that your whole site is built on top of. So a huge decade of transformation for users and for developers in how we think about websites and how we think about our users. So let's take a look at that. Let's take that thread, right? That idea of more people online everywhere, but JavaScript's kind of breakout from the browser. What will define the next decade of web development? I want to posit that it's JavaScript. JavaScript continues its journey out of the browser and into all parts of the stack. What that really means is JavaScript as a universal language. You know, we can run it anywhere. It can be used to build anything. But what that really means is now the front-end developer has the ability to build at all levels of the stack. If you know JavaScript, you actually can get by writing your API with JavaScript. You can talk to your database with JavaScript. You can build a full stack, essentially, all the way down with one language. That ease of use and kind of accessibility to everyone it creates a language that is everyone is incentivized to build for. It's this feedback loop where not only do web developers need to use JavaScript, but they can then also build everything else they need to power that web application experience. It's beginner friendly, so it's also like not a huge upfront cost when compared to other languages. Although that certainly, maybe the next decade sees that goes away as we keep adding features. But for the most part, it's this really nice feedback loop of more and more people getting involved and more being possible with a single language in a way that's never really been possible before. This isn't a new idea for 2021, but this is the trend that's kind of ever since Node really took off, that's brought JavaScript essentially everywhere. And the person who knows JavaScript can build anything with a single language. So I want to take this thread and I want to pull it. Where does this go for web development? What JavaScript is a universal language. What does that mean? And to kind of start that journey out of the decade into the future, I want to look at 2013. 2013 was this really interesting year for two reasons. The first one is that React was released. So React, as I mentioned, took this idea of the front end not as get HTML, get the things you're going to show from the server, and then kind of hydrate them with functionality. React took this very interesting approach for the time, which is your whole component is run in JavaScript. And there might be CSS, but it's generating that HTML for you. JavaScript is the answer in that React world. And this talk is so interesting to go back and look at now, because you can tell how much they're having to convince people, no, hear us out. This is actually a good idea. This goes against every best practice at the time, but trust us. That was essentially their message. At the time, it was this idea that templating and functionality should be kept separate. There are different concerns, but React's big insight was that no, they're not. They're actually the same concept, is that the functionality of the thing is directly tied to how it looks, how it behaves, and what its parts are. So this was a really big transformation, because it took JavaScript not as just we'll add functionality to something that exists, and now we will use JavaScript to build a site, to build parts of a site. The second thing that happened this decade was something that I got to work on, which was this idea of at Box, the company I was working at, we were trying to figure out what this front-end architecture meant for us. So I was lucky enough to work under an engineer named Nicholas Zakis. You might know him for creating ESLint and his numerous writing books. Really smart person. At the time, we were trying to figure out what the front end of Box, the company, should look like. And we had this idea where previously what existed was that same idea that React was looking at, where HTML is coming from the server, and then the front end is just kind of making it work. We started looking at Node instead of React as the way to solve this. So a different model where we saw Node as the thing that the front end developer who knows JavaScript could use to take advantage of that HTML rendering. Essentially moving to a model more like this, where UI was generated, HTML was generated still on the server, so we weren't moving as far as React had gone. But all of a sudden, the front-end developer is now managing a server. So this got at more of the kind of separation of responsibilities was actually changing at this time. The responsibility of the front end before had just been, this runs in the browser, this runs on the server. Hard line, it's like that's my turf as a front-end developer, and back-end developers, that's your turf. The shift was that no, front end isn't front end like no server, it's front end like the UI application layer. It's about that ownership of the application itself, where someone can know JavaScript and own both what runs in the client and on a server. But there's still business logic that can be run by a backend team that understands permissioning, data models, the actual, make sure that the right data is getting sent to the right person is a problem all on its own. So it's funny. So we had these two different approaches where you could look at, the front-end developers world changing. Is it changing through React or through Node? But at the end of the day, what you end up with is something a lot like the single-page application architecture. This is pretty spot on, where the front-end application is running, it's its own thing. You think of the application as a single code base, and then the business logic that powers it is its own service somewhere else, and an API connects the two. So this is the way that a lot of us think about web development today. It's not a big application that spans back end and front end. It's this really nice, clear cutoff between the two. This is a really good architecture for that reason of having a clear separation. So you have not just, good ownership practices, and people who are working on the UI have this full ownership of their experience. But that API, especially within a big company, you have that really explicit contract. So I've seen countless bugs where, oh, if you click this and you click this and you click this, all of a sudden you can do something you're not supposed to do. What's nice about the API is the most secure part of your application. There's no the flow is just an API call and an API response. It's really explicit. You can document it internally. It encourages that. And you can test it on both sides, right? You can just hit that API and test it, or on the UI, you can mock it out and test it. You have this really clear contract between the two. And right, you get to separate out the UI, so you can build for the browser, you can build for native, you can build for iOS and Android. It's all the same API that powers all of that. So you have a really nice kind of organizational structure as well. A lot of code reuse on the most important core parts of your app. And in terms of what you need to know, the front-end developer knows HTML, CSS, JavaScript. They can own the full UI. And the backend can be powered by whatever you want. It could be JavaScript with Node.js, or it could be something entirely different. The API stays the same no matter what. And this is where Jamstack comes in, where Jamstack was this really kind of a bit of marketing, but really a solidification of why this is important as a concept, is because Jamstack, standing for JavaScript, APIs, and markup, you get this really nice distribution model where you can take your UI application, which is essentially just a static bundle of assets, and distribute it anywhere. So put it under a CDN, distribute it around the world, and you're no longer hitting this kind of business logic server that's also doing HTML rendering. You just have a really nice model of really close access to the application and an API for the most important bits. And you can scale that API now as much as you need. So this is a core of what became modern Jamstack. This is really good for developers. All of these things are really good about organizational, structural responsibilities, contracts. The problem was that it was pretty slow for developers. That's a pretty big global statement, but on the whole, it's really easy to build something that's very slow. For example, you're loading a full application of JavaScript code that will then render the thing your user wants to see, versus just sending the user the thing they wanted to see in the first place. It's this like indirect step that gets them where they wanted to go, which is to use your website. And on top of that, you're sending the full functionality. So even if you've solved for that problem, you're sending, every drop down and button click and every part of your site, you're sending what happens when it gets clicked. Your user might not ever even click it. So it's really wasteful in that way, where the user's experience, they're loading a lot of unnecessary things to get the same experience of something that was just sending them the response they wanted in the first place. By rendering it on the device, you get this device level cost, especially as we get slower and lower power devices and more people accessing it. You run into a real problem there. So that's where we're at today. There are people solving this problem now, but that's kind of where the decade left us. I'd say that's our big problem with the site architecture. I'm a UI developer. I want to own my full stack. I want a single code base to power the website that I'm building. What do I do about this? So let's take a look at site architecture. What could we do to take this model, either throw it out entirely or build on top of it? What happens when we keep going down this path? The easiest is that we just keep this current model, right? So let's keep this UI application, this idea of a single page app, but let's address these concerns. That ends up bringing in something to do the rendering for us. So this idea of, I'm not going to send down the full application. I'm going to send down some rendered version of it first. So the user gets back that experience of, give me a website, and the server tells it what it's going to look like ahead of time. That's really powerful. It solves this problem, right? But the problem is that you end up now essentially moving back to this older model that was talked about in that first post, where you now are bringing a server back into the story. So before you had backend APIs, front-end application, API contract. Now you have backend application, server doing some API stuff, and then front-end application, is what the server is doing, but it's also what's running in the browser. A lot of this complexity of the last decade kind of comes from that odd place that we find ourselves. You have a UI application that you're building, but it also has to run on the server and render on the server. It's great when it works, but it also really complicates what started as a very simple story. So server-side rendering is the term for that. Next.js and Remix are two great projects that are exploring that. What if we kind of give you an API for that model? But it's a doubling down, and it's a bringing in complexity to solve that problem. Not necessarily a bad thing, but it gets rid or starts to chip away at the simplicity of the model. That idea of complexity growing, I think, starts to tell a different story or starts to bring in different incentives. So if web development gets difficult to the point where I'm no longer just distributing a set of assets that get distributed around the world and sent to my user, and that's that, I now need to think about a server component. All of a sudden, we start to now have this need that needs to be filled, this idea of who's running the server. Am I running the server? In which case, I need to build it. How do I build it? How do I distribute it? How do I scale it? When there's a need of complexity, especially when the expectation is simple, is there going to be a rise of platforms that rise up to solve this need? So I think Vercel is a really interesting company in that it does a lot of things. It does a lot of kind of agnostic hosting, but their clear connection is to Next.js. They have a lot of Next.js features like analytics, where it's clearly the best host for Next.js. That's the story they're trying to tell, which is really interesting because it's a solution to a problem that is the problem of a solution that they created. Like, it's a solution to the problem of the server component of a UI application getting more complex. So it's a really good experience when it works, but again, it's this idea of, will we have platforms rise up to take on this complexity? A smart hosting platform like Vercel, which can run your server component of the front end and essentially hide the fact that there is this new complexity. You keep building an application, but you're now distributing it to a host that can run a server for you without you even really noticing. React Server Components, if you've seen this, it came out in December, was kind of officially started talked about by the team. This idea of a server component, actually a front-end React team working on server components, I think was a really interesting admission of where they see this future going. The idea of a front-end, what had always been a front-end framework that was rendered on the server, now actually creating primitives for the server. So this is clearly a trend that a lot of people believe will continue. Will it change web development to the point where we think of hosts as these platforms that own the full application? Another part of that story is essentially, I call this slide like the whatever the hell Cloudflare is doing right now. Because Cloudflare is really telling this story better than anyone right now, but it's kind of unclear how it all fits together at this point. Cloudflare has this idea that, well, okay, if you're going to render the application anyway, why not render it as close to the users as possible? So if there's going to be a server, let's move it as close to the user as possible so that they have this really quick connection. A user in Australia isn't going to have to go and talk to a server in New York just to get back this HTML. At that point, it might have been better to just serve them the whole application and have them do it themselves on device. So Cloudflare is exploring this. Okay, fine. Let's take that complexity as is, and now let's build a whole new hosting model for it where things happen at the edge. Workers can render your code. KV is a key value store that actually gives you globally distributed data. Durable objects bring your user data closer to the user so that it actually can work like that. It's a really interesting model. It's just unclear how it all fits together. But in a world where that complexity is taken for, essentially as a reality, as a certainty, this model is really compelling in that it speeds that up even more than anyone else could by running things closer to your users. The flip side of all this is, let's just, at a certain point, if it gets too complicated, are we going to start questioning this single page application, this UI application layer entirely? If we still need a server, well, wasn't that the whole reason we moved away from a Rails model, for instance, where your server-side code and front-end code mixed together? Next.js is really, at its core, a framework for mixing server code and front-end code in the same UI application. So are we really just moving back to an older model? In which case, are these older models actually going to give us what we need anyway? Do we even need to reinvent the wheel? So Rails has been talking a lot about Hotwire, which is a way to kind of send these updates to the browser. Phoenix has live view. There are these solutions which give a lot more front-end reactivity and dynamicism, but using older or more traditional technology that was traditionally only server-side. So maybe we just say, you know what? They've actually done a lot of development over the last decade. We already had this idea of bringing a server in, so why leave the server that we had? I think that's a really interesting part of this of what are the benefits if we're bringing that complexity back in. I don't know if we all appreciate that that's really what we're doing. The other reaction to this, if we pull this long enough, is let's just give up entirely. If this is going to get more complicated, are we now dropping the accessibility of web development? Are we making it too complex for some developers? At that point, if no-code or low-code solutions, sort of like Webflow, and that growing suite of tools, maybe that's just enough. Maybe for a developer who isn't super familiar with web development, maybe that's enough. Maybe they don't even need a full web host themselves and a full application that they built themselves. I think also Shopify is a really interesting story here, where why build a website at all? If Shopify keeps getting good, or some platform gives someone the tools to design their site in the context of a larger product, like I want to sell things, why leave that bubble, right? That could be a really compelling, it's just another type of platform similar to Vercel, but focused on the use case that user was already going to them to solve. So it's web hosting becomes table stakes. I would certainly, I think that's a really compelling story to the users of that, but it drops your options. It's a little more limited. Is that what's best for the web, or is it just the reality of what will start to happen if web development stays complex or grows even more complex? I think one important part of the story and where we can make some progress away from complexity is the tooling. For example, WASM is something that people really like to talk about as a saving grace for the web, right? I can no longer that requirement for JavaScript in the browser. I can write whatever I want, compile it, and ship it to the browser. So Rust, Go, C, whatever language you want can be run in the browser using this layer that is essentially WASM. It takes that story of the JavaScript developer now owning their full stack and kind of flips it, right? It's the backend developer now taking over some front-end development. I think this remains to be seen. I think the trends don't really point to this being a knockout success yet. Where they really point to is two different places, really focused solutions. For example, if you haven't seen Squoosh.app, it's Google's kind of flagship idea of what WASM could be, where it'll actually compress images for you in the browser. It's really fun, and especially if you need just a quick tool, it's actually useful. I find myself using it. That's a really good example. It's a really specific need that WASM solves really beautifully, because JavaScript could never compress an image in the browser like that. It's really a WASM-specific story. The other is this idea of hybrid WASM tooling, which is something that my work has started touching on. So Snowpack as a dev tool for web developers, it's a JavaScript-built tool, but there's a realization that JavaScript itself, it's not great at compute, right? It's not a really heavy-duty tool in that it can't bundle your application or build files and transpile. All this compute-heavy stuff isn't really what JavaScript is good at. But instead of throwing the whole thing out, we can actually start to bring in these compiled tools for really specific use cases. So one really nice thing about Snowpack is that 99% of it is JavaScript or TypeScript specifically, but that flavor of JavaScript where it's familiar to the people who are using it, we get contributions, we get fixes. It's a familiar ecosystem. But for that 1% that ends up doing a lot of work, like how do you build a file for the front end, that becomes something that we can basically farm out to a compiled language, specifically to ESBuild. So we have this kind of hybrid model where the really complex stuff can be handled by a compiled language in a really fast way, but all of the stitching together of that can be done by a language or within a language where the developers and the people using the tool understand the language of the tool. So you still have a healthy ecosystem of contributors around a language that they already know, but you're getting the same benefits of a compiled language and all that speed. So I think we'll see whether that actually changes web development really globally, or if it's really specifically seeded into these really specific use cases, but in a way that reaches all developers kind of indirectly. The other thing that I spend a lot of time on is ESM. So ESM is pretty much the technical focus of Snowpack and Skypack, the two projects that I work on. So ESM is this idea that the browser now has the ability to load code, a native module system of code in the browser. So instead of having to bundle and process and do all this work ahead of time, you can, if you wanted, just send your browser the code that you're working on locally. So I say import this file, I ship it to the browser, and the browser will go out and load all the things I need to run in the browser directly. Snowpack takes this idea and says, okay, great, we'll stop doing this work. We'll give the browser the native modules, and we just get to speed up a lot of our processing time. We can ship updates really quickly because we rely on the browser to natively stitch them in. Skypack takes this idea to the JavaScript ecosystem, which says, do you really want all this processing in your packages? This idea of a package that I've installed, like React or maybe some big package within the React ecosystem. Today, you're doing a lot of bundling and building of those files. You're kind of compressing them and turning them from raw packages, which started out as a tarball that got downloaded, into front-end code. It's a long pipeline to get to the user. What if instead, using that same import, we could just pull the code from a CDN? So in development, you can pull it within Snowpack and kind of cache it. So you now have React. You didn't have to build it. You didn't have to download a package. You just grabbed it as you needed it. And taking that idea even further, why not just ship that into production directly? I think that's what remains to be seen is how far can we take that idea of loading dependencies by URL? If I can load React by URL and I can load all of my dependencies, all of a sudden the majority of my application is no longer my responsibility to bundle and build. I just point to it. I have this kind of pointer by URL. My build is dramatically shrunk. And the speed of my build speeds up, the amount of complexity of my builds. I'm just focusing on the code that I write. That's the model of Skypack, and I'm curious to see how that plays out into the decade. What are the kind of, what do we learn from that model, and does the simplicity that it brings connect with users? I think browser IDEs are the one other place where this gets really interesting, which is taking a look at CodePen, for example. A lot of these IDEs experiences in the browser have always been limited, and we're starting to get smarter and smarter ways to develop in the browser. So GitHub has a Codespaces product that I believe is in beta. Code Sandbox over the last couple of years has been really big. But CodePen is really interesting is that they've, whether through patience or smart thinking or luck, they have stayed really small and focused on front end only. There's not a server or an API that spins up every time you open a Code Sandbox. It runs in the browser. So it gets to take advantage of this idea of the browser now having native primitives. So if you haven't used CodePen in a while, it's really worth checking out because you essentially get a modern dev workflow by pulling dependencies by URL, and it's all running in the browser. So there's not that big startup cost where it's downloading things and starting up a server for you. And if your connection dies, you lose that. It's a totally browser native experience for development that feels as if you're running much more powerful tooling that you're used to. So I see that as being a big trend into the future, is that if the browser is smart enough to handle these things now and can offer a much simpler model, it's a really promising way to bring more people into the development kind of world, into that workflow. Last, I just want to talk about what the user sees throughout this decade, right? Because the 2010s were really about bringing more and more people online. And even for the people who were already online, connecting more and more of the internet into their life. So not only is, if you had internet on a desktop, now that internet is everywhere. It's on your phone. It's buzzing you constantly. Let's take a look at what happens if that trend continues. Hopefully we don't end up in a Black Mirror hellscape. Hopefully this is actually a good trend, is what we're all hoping. I think that trend ends up looking like just more internet everywhere, and not like your light bulbs are now connected to the internet. I mean, if you enjoy that, go nuts. But more the idea of, I try to summarize at the bottom here, your account versus your machine. We still think in terms of terminals and machines. Like even now, I'm recording this on a laptop. And what I wanted to do was buy some new, much more powerful recording machine. I'd have it in here. I could still have my laptop, but how do I share files between those two? I have a nice little coding setup here. I don't want a coding setup over there. We still think of the work that we do on machines as per machine. And I think the future holds more for that kind of cloud-based account model, all the way down to, what if your operating system was just a part of logging into an account? That certainly is a trend that's already started. It just, a lot of pieces have to get into place before the actual lowest level can be changed. Who knows if that'll happen, but I mainly bring this up to kind of juxtapose against like VR as the future. I think VR is really cool, but it's a totally different story. It's not about connecting more people online. VR equipment is, for a long time not going to be cheaper than a phone, if ever. So it's not about connecting more people. I hope it works, but I'm making the point of the internet as connection has been the story of the last decade. And if that continues, we should see more things thought of as connecting to a network versus connecting to a machine. So to bring this all together, this is an interesting talk because normally you kind of set out with a thesis, you prove the thesis, and then you wrap it up. In this talk, I set out with a thesis and then just kind of like, what if this happened? So there's not really like, and here's how I proved my point. The thesis was not proven. It essentially was the excuse to talk about all this stuff. But I do think that there are some kind of common themes and things that you can bring into your kind of the way that you see the web today. The first is that story of the lines between the front end and the back end will continue to blur. We either will solve this performance problem of the single page application, of the kind of full UI application. We'll either solve it with more server logic, or we will move away. Or maybe there's some third answer to this problem, which is a reduction of, maybe can we get rid of the server? That's one of those things where, is there a groundbreaking technology out there that will actually change this framing completely? Maybe. But barring that, we have this performance problem that we need to solve. And the way it looks like we're solving it is by adding more complexity and more logic and more server-side components to the front-end workflow. So what solves for that problem? Do we leave it? Do we build on it? Who knows? It's a blurring of the lines that is adding complexity. And I think that will define what happens over the next decade, is how we respond to that complexity as developers. And as someone working on tooling, I can't help but feel like there is a tooling answer here somewhere, right? This idea that we have spent the last decade processing and bundling and using tooling to solve limitations in the platform. But the platform's grown up, and we now have a browser that can actually run code the way that we think about code, which is dependencies, connections. We have browser primitives that help you load an application that looks a lot like the application you're building. So tooling in the next decade should hopefully be able to take advantage of all of these features, all of these primitives, and build a much simpler tooling workflow for the people building for the web. So if that excites you, please check out Snowpack and Skypack, 2 projects that are looking at this problem today. That's my talk. I hope this has been really interesting and exciting. I hope we don't get killed by attack dogs and killer bees. And if we're all here in a decade, please set a reminder on your phone, bug me in 10 years and let me know how I did on this. But thank you all for your time. Really appreciate it. Thank you very much. Whoa.
Fantastic, Fred. Thank you so much. That was an excellent look at the future.
Thank you.
I'm gonna throw the banner back up. If I can find the link to the thing, where's the banner? Here we go. If you have questions and you're watching, then please drop them into the discussions. Well, let me ask a couple that I've already queued up while you've been talking. One of the questions specifically around sort of Skypack and dependencies is that loading public code from a URL sounds scary. What's the security story there look like? And I know that there's prior art there when it comes to Deno. Deno makes an argument that this is basically how browsers work. So if you're okay with how browsers work, then you should be okay with how Deno works. I assume you have some more insight into that than I do.
Yeah, it's how browsers are already working, but it's also how NPM and the NPM ecosystem that we all use today is already working. So the idea of loading code from a URL isn't too different than loading code from an NPM package name. What NPM's doing is turning that package name into a URL of a tarball that it then downloads for you. That doesn't mean that it's less of a risk or more of a risk. It's a model that we all already implicitly have bought into, but making it much more explicit that you have this URL. Especially in production, I think that is where there's a difference here. You are now, especially if you push this to production, there's a URL that you're pointing to that is loading code in production. So I think that's where we need a little bit of a browser catch up. For example, the ability to fingerprint some of the things that we load from a CDN like Skypack, so that if it changes at all, the browser is like, no way, I'm not doing this. But there's also benefits to this model where if you think about what you get with NPM today, you put in a package name, NPM downloads that package name and then has full scripting capabilities on your machine. So if you get a typo or if one of those packages gets hacked, NPM, essentially anyone in your dependency tree that owns a package has the ability to push a script up to you that gets run on your machine with pretty much full access. So there's already security concerns. It's a different security model. I think for the most part it's better, but it's different, and there's definitely pros and cons.
I think there's a related follow-up question here, which is how are dependencies managed or pinned with something like Snowpack, and specifically maybe going forward with the streaming imports? Is it just, we're relying on URLs and having sort of versioning tokens in the URLs, and then so long as I'm still referring to the same URL, that's the package?
Yeah, it's an interesting new set of, it's like we have this whole ecosystem built up with NPM and package lock files and locking things down, and then, okay, throw that out, what happens next? Deno takes the stance that no, the URL is the lock. So the URL goes into the code, and that's essentially what you are loading from. So they kind of push this problem out. They say, we don't want to deal with it. Snowpack tries to answer this in a little bit better way, because I've tried writing full import URLs in my code, and I don't really enjoy it. So the convenience of writing a package name and getting that's something that I definitely care about as a developer. Snowpack will essentially lock it down for you behind the scenes, so give you something a lot like a package lock file that has your versions. And then the development experience of working in Snowpack, if you want to connect to a CDN like Skypack and have that streaming imports feature where we just load dependencies over the wire, you're essentially using this lock file to translate that package name into a URL to the specific version that you want, so that doesn't change over time. You get a really locked down experience. It's the same model as an NPM, but instead of running an NPM install, you're just getting it as you develop. So borrowing from a lot of those same ideas.
Right. Okay. I have a question from Luciano Ratamero. Hopefully I said this correctly. He's asking, how would I know at a project level what are the dependencies and their sizes? Something like what Webpack Bundle Tracker does for me. Like, how do I sort of get a grip, especially if I'm not pre-installing it and therefore can just walk the directory tree and see the file sizes and whatnot? Like, how do I get a sense for like, oh man, I'm shipping 4 megabytes of JavaScript to my front ends?
Yeah.
Make sure I don't fall into that trap.
Yeah, right. It's if you have a URL that's kind of like all you get for free is like, okay, there's code there, right? Like that's where React lives, but oh god, it loaded 10 things. Part of it is really on the CDN to surface that information. So it's really why we focused on having a catalog to back up Skypack and putting more and more information about a package within that catalog, so you can kind of come to learn about the package through the catalog and understand what's inside. The other nice thing about Snowpack, and it's kind of interplay between the registry or the CDN and the tooling that uses it, is the tooling kind of has that responsibility to tell you in the same way that Webpack currently tells you how big your packages are. Snowpack, the new tool that talks to these things, it's kind of on that tool to tell you. So one nice thing about Snowpack streaming import support is at the end of the day, your build, we haven't made the jump to putting URLs in your final build yet. That's still a little bit more radical idea. You can do it, but it's not our default. Our default is to pull the code and bundle it into your application. So the end result is that exact same story. You can see via the final result how much code you pulled in, what your dependencies look like, and what their performance impact on your site is.
Right. Interesting. I like, I'm personally wondering if there's going to be, in the same way that sort of the React dev tools made React development a lot easier by having something that's sampling the thing that's actually produced in the browser right there in my Chrome or Firefox DevTools. Maybe there's something that's going to sort of like emerge on that side that's less focused on here's all the stuff that went over the wire and more focused on I'm aware of your dependencies and what dependencies they're pulling in, and sort of like another display of that same information, like, you know, for the developer in the browser.
Yeah, I mentioned on a slide the Webpack Module Federation, I think it's called, deserves a call out because it's not ESM based, but it's spiritually very close to what ESM allows, which is, I'm blanking on the developer's name who's working on that. I apologize, but there's a lot of work going into a dashboard to manage your dependencies, and this idea of actually being able to kind of hot patch an update to a dependency from some UI. So this idea of connecting your dependency graph to a UI dashboard. They're starting to take a look at that for that exact reason, to have a little bit more of a connection to what's being run and being able to kind of navigate it and almost live update it. It's a really interesting idea that we haven't really dug as much into, but certainly a compelling story there.
Awesome. We still have a couple more minutes and a couple more questions. So yeah, maybe we'll switch gears and ask about what about the distributed web? This is maybe sort of in parallel or orthogonal to all this development, but all of these novelties that you highlight, they're still like, you know, more bricks on top of the same building that we've been building for the past, I don't know, 20 years, whatever. Whereas now we're starting to look at all these quote unquote decentralized or distributed web technologies, things that permit local first apps, not relying on central distribution of your static app, technologies like IPFS and Beaker browser. And before that, there's, I'm blanking on the thing, but it was DAT, DT. Thinking back a few years, where do you see these sort of in relationship to this growth of technologies for building and using the web itself for delivering the dependencies that are needed to build?
Yeah, it's a really interesting part of this. Like, whether you love blockchain or hate blockchain or think it's amazing or totally fake, like, it's essentially a funding model for a lot of decentralized projects. So who knows if it'll pan out, but there's certainly some early promises showing in those projects you listed of using something that has a distributed backing to rethink even, this idea of a server. Especially if we tie that into the story I was telling around like this rise of the platform and stopping to think about like, I have deployed a server and more just like I deployed to this company and they've figured it out for me. What does that look like in a model where there doesn't even really need to be a company or a server? There's just this like distributed mesh that you deploy to, and it's just kind of this living, breathing, dynamic thing that has no owner. It's one of those things where it's a really compelling story if they can get it right, and there certainly are a lot of people trying to get it right now. So there's a project called IPSQL that Michael Rogers is working on, which is really like the perfect kind of like mind-blowing way that this could pan out, which is still very early, but it's this idea of a SQL database backed by IPFS. So a SQL interface for a distributed data structure. So build your next application on the distributed, app, or on the distributed, kind of network that is IPFS. It's a really interesting story that's still so early. It's still, you really have to fiddle with a lot of tooling yourself, but if you can get it working, it's I don't know, it's fascinating.
Yeah, I know that there's some interesting work coming out of Ink and Switch. I don't know if you've seen the Cambria white paper about the sort of how do you do data migrations when you can't count on everyone having the same data model at the same time when these things are separate, and how do you build apps that are going to be robust in the face of like, I'm version 44, you're version 42, like I don't want to like split the network and make it so that like I can only speak with 44 and up, and you can't talk with me.
Right. It's a very different model where you like almost as a user of a site like that have your own database that then talks to the main database, and like you say, like you're much more of a client syncing with a hub versus like, okay, stream this website down to me, stream everything down to me. Yeah, there's really, it's a very different way of thinking that even I am still, not an expert on at all.
I'm looking for more questions that have appeared in that there was one question that's related to this. How do you think about local first functionality fitting into these architectural changes? How can we support user-centric local first models while moving towards the UX benefits of the account-oriented approach that you discussed?
Yeah, I think that's part of what needs to be decided. The browser ecosystem, especially Google, really cares about this. I think Google as a company sees this as like a more philosophical battle of like web versus native, right? So I guess Apple would be the other side of that story. Like having the web browser be a first-class application platform, because it allows you to connect to this kind of way of thinking, which then as a company benefits them. So their incentives are certainly, it's not just a moral win for them, it's also a financial one. But having that company backing the web in that way leads to a lot of interesting features around the web platform as a kind of local native app experience. So Houdini is a project that a lot of these ideas come out of on the web end. A file system API for actually reaching into the file system on your computer. Even Chromebooks, I think, are kind of an interesting part of this, or they kind of are pushing that idea of a low-power device that you log into via an account. All the pieces are kind of mixing around and melding around, so it feels like there's a vision there somewhere.
Yeah, I mean, it's definitely something that my team is thinking about a lot in the context of something like code spaces, where if I can have a development environment that is purely cloud-based, I can now consider swapping this incredibly expensive MacBook for some $500 Chromebook and still have a development experience. But the problem with this fantasy is ultimately, eventually, I need to be able to operate on stuff on my local file system, and like eventually, at some point, I run into a brick wall, and then I miss my MacBook, and so like it's not quite there.
Yeah, right. There's always one more thing with it. That's like Chromebooks are helping a lot of people, but developers are like, there's always one more thing for a developer. I've tried a couple of times to move over to an iPad for coding, and there's always that one thing. Eventually, there would hopefully not be one more thing, but for now.
Okay. We have time for one more question. So let me make it a really difficult one.
Oh, great! And on an incredibly low note.
reach for the. So it's clear. You touched on WASM as sort of a path for perf-sensitive code. I want to process a bunch of data or imagery or do machine learning or whatever. All these things are sort of great targets. Anything that can happen sort of outside the main thread. WASM offers a lot of opportunities for performance optimization. What's less clear to me is where the interaction point with regular code is going to be. Are we going to see sort of a mirror of like the last 10 years of JavaScript happen again with WASM, that in the beginning it's going to be ill-defined, and I'm going to be leaning on like a lot of tooling to make my life like to give me an experience, while like sort of the primitives catch up to the point that we no longer need like layers above or polyfills. Are we eventually going to be compiling stuff for the web like we compile other software? Like I have a tool chain and it spits out a binary, and I like put the binary up somewhere, and like I invoke it. Like what's your sort of like your sense for how that's going to feel like over the coming years as sort of this becomes a little bit more mainstream? Yeah,
that's a great question. I think that what I always get stuck on with WASM is that most front-end developers aren't asking for WASM. What they're asking for is like the features of WASM, but then if you're like, oh great, just throw out everything you know and try something new, it's a little bit of a harder story. And that even assumes that there are no, that the technical limitations match up with what they're used to. I think what we've seen a lot of success in up to this point is I have a really specific need and WASM solves it, right? So it's like I integrate WASM into my application. I think that will continue to happen. That makes so much sense. the kind of like white whale of a lot of front end thinking is this idea of what if we can move the application logic off of the main thread entirely? So what if we could have your rendering just kind of be like priority number one on the browser? It's its own thread. It never gets blocked. It's always just rendering. And then like the application logic happens somewhere else in a different thread. Like React concurrent mode is kind of an attempt at that idea of at least, you know, not blocking when you run code. There could be a way that like WASM solves for that. If you think of WASM as something that runs off of the main thread and kind of gets its own worker, and maybe that's a communication between the two. If WASM code could output instructions for a renderer, it's less clear to me how that could all fit together. But in terms of, okay, what is the need that this could solve? There is this need for, especially as applications get more complex and user expectations rise and rise and rise for more dynamic, more native feeling applications built with the web. Is there some way to power it with something that isn't a traditional JavaScript application that all shares one thread, and power it with something else that then talks to a rendering engine?
Mm-hmm. Do you think that we're going to see that what's like impeding adoption of things like WASM right now are just, is it just like developer experience things? Like, you know, if WASM was easier to target, easier to build for, even using languages that I, as a web developer, quote unquote, already know, like, you know, I don't need to reach for Rust to target WASM,
Yeah.
write TypeScript and target WASM, but it's like so complex and whatever. And like, I don't, you know, as a web developer, like I don't know it off the top of my head. It's not like everything I've done before, and therefore I don't reach for it. But if someone made it easier, then it would see more adoption and usage. Or is it just that it's like the tech isn't ready yet for like widespread adoption? Like, where do you think are sort of like the biggest pain points there?
Yeah, I think right now it's a little bit of everything, right? So it is a more technical lift to integrate WASM into your site. There's just, you know, there's a whole suite of JavaScript tooling about building HTML, CSS, and JavaScript, and then not as much for someone building for WASM. And kind of every community, as far as I can tell, kind of needs to work on their own. Like the Go community needs their compiler, the Rust community needs their compiler. So there's a little bit less shared work than you would hope for, and just more of a technical lift, given that it's so new. I think there's a size component as well. So a lot of WASM thinking, or a lot of, you know, compiled language thinking is, okay, you see this in gaming a lot when people try and build gaming for the web and trying to use WASM for this. It's this idea of a big compiled, you know, it's bundling essentially, this compiled artifact that gets shipped to the browser. It's pretty heavy, right? If it has all these assets and code that's been compiled, it's just the performance story isn't really built on the same one that the web has refined for 30 years. So there's a little bit of a technical story, but then again, I just think that there's not as many people asking for it really in their day-to-day. I think they want the idea of a faster site, and I think everyone would love the idea of, yeah, better performance, but no one wants to drop everything they know. So the user audience kind of doesn't match up. The person who loves WASM, it's not really the traditional web developer, at least until they can create a story that is so compelling. Okay, I will learn how this works because I want that thing, whatever that thing is.
Mm-hmm. Okay, fantastic. Fred, thank you so much for coming on and sharing your wisdom with us. That was a fantastic talk. I'll remind everybody that the discussion thread that I linked earlier is going to stay open, and if people want to keep engaging or answering questions there, absolutely, please do. We're happy to sort of foster a community of people talking about these things. Fred, from all of us at GitHub, thank you so much, and everybody have a lovely day.
Yeah, thank you.